How is it, everyone? And welcome to your first class math tutorials. And in this tutorial, we're going to look at direct variation. So if you look here in this fig 3.6, this fig 3.6 shows a piece of metal cut into a number of pieces. So let's see this diagram as a piece of metal which has been cut into different lengths. So if we are looking at this steel or a piece of metal, the mass of each piece is proportional to its length, meaning to say this length is going to weigh more than this one or this one or even this one. So the length of each and every piece is going to depend upon the length of each piece. So this is an example of what is called direct variation. And if you also go further, the ratio of mass to length is the same for all pieces. So this is what we call direct variation. And if you look at the statement number 2 here, which is saying if a person walks at a steady speed, the distance traveled is proportional to the time taken. So looking at these two statements, we are looking at what is called direct variation. So basically, when we are looking at direct variation or proportion, if we look at the first example where the mass of each piece is proportional to its length, this statement can be written in short like M varies directly with L. So this simply means the mass varies directly with the length of each and every piece. So this sign here simply means varies with. And if we look at the example number 2, whereby a person walks at a steady speed, the distance traveled is proportional to the time taken. So this simply means distance varies directly with the time taken. So this is the example of what we call direct variation. And the ratio of the masses to the length is the same for all the pieces in this first example. And if we look here at as well, the ratio of the distance which is traveled is also the same with the time. So when we are looking at direct variation, this is basically what we will be looking at. And if we look at the question here to illustrate the topic of direct variation, it is saying if D varies with T and D is equal to 80 when T is equals to 5, find the relationship between D and T. And the question B, the value of T when D is equal to 56. So if we want to solve this problem, we've got D varies with T. So this implies that we are going to introduce a constant, which is basically a small letter k. This implies that D will be equal to kt, right? And then to find the relationship of these parameters, we are going to substitute D and T so that we find the value of k, which is going to give us the relationship between those two parameters. And then D is equal to 80. We are going to say 80 is equal to the value of T is 5. So 5k. And then we are going to divide both sides by 5, both sides by 5. And to find the value of k, the constant, the value of k is going to be 16. So if we want to write the relationship between D and T, we are going to have a relationship like D is equals to 16T. So this is going to be the relationship between those two parameters, the parameter D and T. So moving forward with the part B of the question, which is saying find the value of T when D is equals to 56. So we've got the relationship already, which is D is equals to 16T. So now for us to find the value of T, we are simply going to substitute 56 in place of t, and we are going to have 56 is equals to 16t. Divide both sides by 16, divide both sides by 16, and t is going to be 3.5. So this is the value of t. So this is the concept of direct variation. And always remember that practice makes perfect. And I'm going to bring more tutorials with questions on direct variation so that we can practice more questions, and then we will look at other variations, because basically we've got almost 4 variations, and this one is the first variation, which is called the direct variation. So if you look at those two statements first, you understand what we call direct variation, and then going further we will be introduced to the signs that are used in direct variation and the statements that you can deduce from those variations to create equations, and then solve for any value that might be required, so that you can be able to see the relationship or between 2 or 3 variables. So this is basically what we call direct variation, and more tutorials are on the way. Always remember that practice makes perfect.